All right, 3.4 measures of position and outliers. All right, so first objective is look at this thing called a z-score. Now, our z-score represents the distance that a data value is from the mean in terms of standard deviations. So it's how many standard deviations are we from the mean? Are we 1 standard deviation, 2, 1.5, so forth with those? So we can calculate that, all right? Now, I do need to make a correction here. This coming from the book, they made a small mistake here. This is not mu on this z here. It is sigma, okay? So that sigma that they use there, the standard deviation. Now, they use S properly over here on our sample. S is our standard deviation for sample for those, but for some reason they decided to put mu there, and I don't know why for that. So they were probably just going a little fast and didn't correct that. And I can't type over it, so I couldn't correct it myself either. But I'm correcting it now within this video, okay? And so you're going to have to just have this memorized, okay? It's going to be our z-score is always whatever score, whatever our individual score is, minus the mean divided by the standard deviation to get our z-score for those, okay? So that's what we want to look for there. All right, so for instance here, we have the Boston Red Sox and the Dodgers here looking at some things. So they want to look at the individual pieces and wanting to know how many standard deviations or what is the z-score for these, okay? So we can see the runs for the Red Sox. We can see their mean, there's mu. We can see sigma, their standard deviation for that, okay? And so we can plug all those things in. And so we move here for the Red Sox. We would plug those numbers in. Now again, those mu's are supposed to be sigmas. So sigma and sigma here for those, okay? And so when we plug those things in, and you go back and look at the previous slide, you would see that sigma does match those things and do that math. And so that means that the Red Sox are 1.99 is a z-score, 1.99 standard deviations to the mean. And it's positive, so it's going to be on the right-hand side. Whereas the Dodgers are 1.55 standard deviations from the mean. Okay? All right, so that means that the Red Sox had a better run production, okay, because they have a greater standard deviation there from those, okay, pieces. All right, the next piece is looking at percentiles. So the kth percentile, denoted here by P sub k, is the set of data values such that k% of the observations are less than or equal to that value, right? Now we hear a lot of this more in like children. When you take, if you have a kid and you take them to the doctor's office and they measure their weight and they measure their height, they'll say they're in the, 75th percentile. That means that they are bigger than 75% of the other children out there at that age with those, okay? And so they look at those things. So it's always there, that number, everything, that percentage is less than them on those, okay? All right, so for instance here, we also look at exam scores. It says that she took this math score of 600, is in the 74th percentile. What does that mean? It means that 74% of the other people taking that test scored less than 600, and 26% scored greater than 600, okay? All right, quartiles. Now, if we take those percentiles and break them up into every 25%, those are what we call quartiles. And so the first quartile is at the 25th percent, the second quartile is at the 50%, third quartile is the 75%, and we don't call it the fourth, but 100% there is our largest data value on those, okay? All right, and so again, it breaks those things down, what it means here for those, which is what I pretty well said. Okay. All right, now if we need to find the quartiles, we can determine the data, what's the mean, and all of those things for those pieces. But we're again going to allow that calculator to do that work, okay, for us here. So let's put this data into our calculator. It's going to take me just a moment. So again, I'm going to clear. I need to go into stat. I need to edit my L1. So that needs, I don't need an L2, so I need to clear it. L1 I'm going to clear, and then I need to put in all of these numbers, okay? So right. I'm getting there. Let's see. I keep up with where I'm at as I go here. I'm trying to pay attention. Oh, see, almost messed that one up. Always good to check your numbers as you go down through there. We've got a lot of things going on those. Now we had 18, and so my last number was in the 18th spot. So that's good. We can see that there in that little parentheses, 18. So it lets me know how many I have on those. Okay. All right. So let's go back and do our stat over to calc. And again, number one are 1var stats. Now this time we can just press enter for those. All right. So now we want to just go down. So if we go all the way down here to the bottom, we can see all of those numbers that they are wanting for us to have here. Okay. So even though they did all those pieces, we found our Q2 or our M is our median, 1805. We agree with what they have here for those pieces. Okay. Now they're breaking it down and actually picking out the numbers, but the calculator does it. They found that Q1 should be at 735. Look at ours, 735 with those. And then Q3 should be there at 4668. Well, look at ours, Q3 is 4668. So by going back into those 1var stat, we don't have to write all those numbers down, figure out, make sure those things. We just need to put it in that calculator, and then the calculator will give us the numbers that we need for our quartiles. Okay, and just remembering that Q1 is listed, Q3 is listed. Well, the median is Q2. So if they ask for Q2 instead of median, we have those numbers there still. Okay. All right, and so then we could talk about all those things that 25% is less than the 735, 75% is less than the 4,668, and so forth on those pieces. Okay. All right, and so here again, they do different different programs to get the same things. Okay. All right, so the next thing is what we call the interquartile range with those, and that's the middle 50% of those. Okay, so we always kind of like to know what that middle group is on our pieces. Well, that's called our IQR, the interquartile range, and that is simply Q3 minus Q1. All right, so our third quartile minus our first quartile on those. All right. And so from our previous problem here, now they don't give us this, so we have to do this math, but we would take the 4668 minus the 735, which is what they're doing, and we get 3,933. Okay, so that's the range of 50%. We should have 50% of our observations within this $3,000 or almost $4,000 range on those. Okay. And so then if we needed to, we could calculate any of those pieces moving forward there as well. Okay. All right, so again, just kind of remembering if we have symmetric, you want to use the mean for your central tendency and standard deviation for your dispersion. But if it's skewed left or right, you probably want to use the median or the interquartile range for your pieces. Okay. All right. Now the last thing is looking for outliers. Is a number legitimate within our group, or is it really kind of far outside of the rest of our group? Okay. So extreme observations there on those, okay? So first thing we would do is find our first and third quartiles, okay? Compute our range. And then we're going to look at what we call fences. And these are our cutoff points. Anything outside our fences would be considered an outlier, okay? Now to find our fence, we have these formulas. Again, you're going to have to know these formulas. So we have Q1 minus 1.5 times the IQR. Now 1.5 is given. Now it's always in those. Then the upper fence is Q3 plus. So anything that much smaller than Q1 or that much bigger than Q3 is going to be where our fences are, okay? All right, so let's look at our table here. So we found those Q1 and Q3, okay? Now our IQR we said was 3,933, okay? So now we found our lower fence. So we take the 735 minus 1.5 times 3,933, and we get a negative 5,164.5. So that's going to be in the negative. We have to be losing money with those. Now our upper fence, we take the 4,668 plus 1.5 times that 3,933 and 10,567. So an outlier has to be less than the negative $5,000, but greater than the 10,500. Okay. So since we had one claim that said 21,000, that would be an outlier to our group. It would not be less than that 10,000 mark. Okay. All right, so those are the things that you want to look for here in 3.4, paying attention to all the different little bits and pieces to this. All right.